Alright, welcome back, boys and girls. It's your main mathematics coming to you live from Mayfield. In this video, we're going to be working through this real simple equations quiz that you should have been able to check any and all of your answers, so that way you got 100%, but I want to make sure that you do know how to do it. So in the first one, it says solve the equation for x and check your answer using back substitution. So that's where you take your value for x and you substitute it back into the original equation. So you see what I am talking about in just a moment. And so anytime you see an equal sign and you want to solve, again, we're going to use that distributive property, combine like terms, and manipulate the variable. And so we can see in here, again, we want to group those like terms on one side together. And so we're going to say that negative 7x and that positive 9x, since those are like terms on one side, we can put those together. And so we could say combined it is 2x, everything else comes down, so we have a plus 1 and we have equals 23. Now we can get since all the variables are on one side, all we have to do now is get the constants on the other side. So we're going to try to get rid of this positive one, so we add to the opposite. So we're going to add a negative 1 to both sides. And so now we have, again, the ones cancel out, everything else comes down. So we have 2x, and then 23 minus 1 is going to be 22. So once we have all of our variable terms on one side and all of our constants on the other, now we can just divide by the coefficient. So we're going to divide both sides by 2, since that is our coefficient. Again, once we divide both sides by 2, we know we can have our simplified answer. So again, we have x equals 11. Again, always circle your answer so that way you know where to check. Again, you can check to make sure your answer is correct, again, by using that Desmos calculator or by back substitution. And so I have everything where I had an x, I now have an 11. So let me actually type, let me see if I can type in. So originally, this is what you had. You had 7x plus 1 plus 9x equals 11. And so now we have x equals 11. So anywhere we had an x, we now have 11. Again, you can use your order operations to simplify. And so we're going to do that negative 7 times 11 is going to be 77. Everything else stays the same. And then we can do 9 times 11 is going to be 99. And then we have, from left to right, we have addition and subtraction, but we're going to do that negative 77 plus 1 is going to be negative 76. Everything else comes down. Again, the whole time we're saying, is this equal to 23? Well, very simply, you note that you do end up with the right answer, since negative 77 does equal 99. Again, a way you can check that is like this. Let me actually pull up that Desmos calculator. Let me see if I can do that real quick for ourselves. Type in that Desmos page, pull it up for ourselves. Get that reverse contrast, and there it is. Alright. So again, typing in for ourselves, I'll put it off to the side here. So again, I type in and I say, alright, I type in exactly what it says. I have negative 7x, I have plus 1, and I have plus 9x. Which is what that says. Let me actually make that a little bit bigger. Alright, perfect. And so again, notice how it has that triangle there. It's saying you need to define what that variable is. And so that's where we type in our answer. And so again, we don't hit equals right here because we're trying to say, hey, I need to figure out what this expression is. Well, we said, hey, I think x is 11. And since it does match our original equation, again, notice how this 23 is exactly what we're looking for. And so we know we are good. Clear that out and move back. All right. So now in the next one, it says 4 students are comparing each other's work for solving equations. Which equations are solved correctly? So if you actually read that carefully, you notice, hey, I have that there are 2 answers that I need to check off, or at least more than one. And if you look at the answers in the bottom, you can also see, hey, I can have and try out these answers. So let me actually do just that. So let me make this, let me come back on this one again. Let me actually make this smaller and bring this down just a smidge. All right. So what I'm going to do is I'm going to type in that original equation. So I'm going to say 3 times x, 3 times the quantity x minus 1. And I'm saying that needs to be able to equal 15. And so if I wanted to, I can try out these 4 answers to see which ones are correct. And so I'd say, does that equal 16 over 3? I get a nice answer of 13. However, that is not my answer that I'm looking for. So again, this is one way of checking to see if this works. So I can mark that one off. Let me check off. All right, let me go back on here. So I have x equals, oh, my next one is 6. So I can try out 6. Oh, it does equal 15. And so we know we're good. Again, we're looking at this value right in here. Since it equals 15, we know we are good. Trying one more on the side here, we say x equals 8. Again, since this value is not 15, which is what we're looking for, we know that we cannot include this one. And lastly, we actually notice, hey, it is the same as the one before, and so we know this one is an answer. Even though they did it a little bit differently, there's always multiple ways to get to Central Park. As long as we end up in the same place, we are good. If you want to be able to see it where their mistakes were, you could see that, hey, when they distributed the 3 to the first one, so we had 3 times x, it should be 3x, and they should have 3 times a -1, and so this should be a -3, and so that's why it's wrong right there. And then in the third one, let's see, what did they do wrong? Well, when they divided both sides by 3, they ended up with 1x, which is right, but then they should have had a -1 right here. So similar mistake, but you want to make sure that you are seeing those. Again, you could have solved these very straightforward. You could have also just solved for yourself to see what your answer is and moved on from it. Again, this one was super simple if you were just looking carefully to the answer choices. Alright, moving on now. So now it has, using the given key, write the equation that represents the model, then solve for x. And so, again, I'm just going to draw out, or excuse me, it's already drawn out for me, but I can take and write out my equation. So again, using this key right here, I know I have how many of these? Well, I have 2, and it has negative x's. So I have -2x. And I count 1, 2, 3, 4, 5, 6, 7, 8. I have +8. That's not a +8. This is +8. Alright, so that's on the left side of the equation. Again, right in the middle is the equal sign. And on the right side, I have 1, 2, 3, 4. Well, what are these? I have 4 positive x's. So I have 4 positive x's. And I have 10 negatives. So again, make sure you can see where I get these from. Again, it's just 2 negative x's, 8 positives, 4 positive x's, and 10 negatives. Alright, so now, again, when I want to be able to solve it, you could have solved it using the picture model if you wanted to, or you could also do it how we normally do. And so again, we want to have out that DCM, again, distributive property first. Since there's no parentheses, we don't need to worry about it, so we can cross that one out. Now we want to combine like terms, so we want to get all those variable terms on one side. Since we have variables on both sides, you want to make sure that you can look for the one that is lowest. So we look at the two coefficients, so we look at -2 and a +4, and so we know that we need to add the opposite to the lower coefficient. So we're going to have +2x to both sides, or +2x to both sides. And so we say, okay, what do we get now? The 2x's cancel out, and so we're left with everything else comes down. So we have 8 comes down, equals, we have 4x plus 2x is 6x, and then the -10 comes down. Still, same idea, you want to make sure that you can get since all the variables are on the right, we want to get all the constants, meaning the numbers, to the left. And so we have to get rid of this -10. So what would be the opposite of that -10? Well, that's going to be a +10, so we add 10 to both sides, and so we add 10 like so. And so what do you end up with? Very simply, we're going to have 18 equals 6x. And then lastly, always want to divide, since we're done with this combined like terms, we want to divide by the coefficient. So divide both sides by 6. And we should end up with x equals 3. Again, to be able to check for ourselves, let me see if I can actually bring this in. So let me move this over to the side. I'm going to save this here. Bust out that Desmos calculator. Let's make this a little bit smaller. Alright, so again, I'm going to say this. I want to make sure that if I have variables on both sides, I need to make sure that I type it as two expressions. So on the left side, I'm going to have in green here. So I'm going to type this in here. I'm going to type in this -2x plus 8. So I have -2x plus 8. I hit enter, and then on the right side I type in that amount in pink, and so I have that right there. And so I'm going to type that in. I have 4x minus 10. Again, it's looking to define those variables, so let's type in to see what our answer is. So I said, I think x equals 3. Again, since these two lines are equal, meaning the -2x plus 8, since that equals 2, and the 4x minus 10 also equals 2, we know that we have a balanced equation, meaning both sides are equivalent. Alright, moving on. Alright, everybody's favorite distributive property. So again, you can solve for x and then check using back substitution, and we'll also show using that Desmos calculator. That way you have both methods. So again, make sure you can have that distributive property combining like terms, manipulate the variable order for yourself. That way you know what to do. And so what we've been doing is we say, all right, I believe it's going to be like this. So again, you can draw your box. Let me actually put this off the side here. Move this along a little bit. Something like that. And perfect. Alright, so again, I draw my box to be able to show, hey, this is how I do my distributive property. So again, I multiply these two together. So I do 0.5 and 8x multiplied together is 4x. And then I do 0.5 and 2 multiplied together is 1. So now again, I only do that anytime I see those parentheses. So I take that outside amount and I multiply it to each of the inside terms. Once I have those products, I can write it right below that expression. So I'm going to take and write it like this. I'm going to have 4x plus 1 equals 3x plus 17. Again, notice how everything else stayed the same. So we can cross out that first step of the distributive property. Now we want to combine those like terms. Since we have variables on both sides, we want to look for the one that has a lower coefficient. So we see, okay, which one is lower? So I'm going to actually move this back to the side here. So which coefficient is lower? I have a positive 4 and a positive 3. We know that the positive 3 is lower, and so that's the one that we're going to add the opposite of to both sides. So the opposite of positive 3x is a negative 3x to both sides. A little bit too much on that one. There we go. And so what are we left with? Well, the 3x's cancel out. The 17 comes down, and the 1 comes down, and so we have 1x, because it's 4x minus 3x, equals 1x. And then we have 1, and the 17 comes down. Again, make sure you're on the correct side of the equation. If you happen to draw something on the left side or the right side, that shouldn't be there. It will change every little bit. Now that we have all the variables on the left side, we can pull over all of the constants to the right side. And so we want to get rid of this positive 1. Again, to be able to do that is we add the opposite, so we add negative 1 to both sides. And so we are left with our simplified answer of x equals 16. To be able to check, again, like I had before, you type in, or excuse me, you plug in exactly how it looks. So originally we had 1/2 times quantity x plus 2 equals 3 times x plus 17. And we type in, I said it again, we plug in our answer. So anywhere where we had that x, we now have a 16. So that means both sides of the equation. And so all we're saying is this left side equal to this right side? Again, you can simplify using your order operations. So we're going to work on the inside of the grouping symbols first. And so I'm going to do 8 times 16. That's going to be 128. And on the right side, I'm going to do 3 times 16, which is 48. Again, combine inside those grouping symbols again. And so I'm going to do 128 plus 2 is 130. And then I have 48 plus 17 is 65. One last step to make sure we're balanced. Again, you should keep that equal sign the whole way through. And when you get to the end, it should have the same thing on both sides, so that way you know you are correct. Again, I can also show using that Desmos calculator. And so I say this, let's move this check over here and make it a little bit bigger. And so I type in exactly how it looks. So I have 1/2. I have times 8x plus 2. Again, I have to type that left side in of the equation first, so that way I can, did I have green before? Yeah, I did. Alright, let's do green again. So on that left side I do green, and then on the right side I have to start a new line. So in that pink that I boxed in, I need to start a new line. So I have 3x plus 17. Again, it's looking to define those variables first, and so let's type in what our answer is. So we're checking to see, does it equal 16? Again, since both sides are equal to 65, meaning both the green expression and the pink expression are 65, we know that our answer of 16 is correct. Alright, last but certainly not least it says draw the model for the given equation using the key, then solve for x. So what I'm going to do is I'm going to actually draw the model first and then solve using the box method, or excuse me, drawing the pictures, and then I can also do it how we normally do with the algebraic way. So again, I draw the left side. Again, notice how the right down the middle is the split. And so let's see, I have 8 negative x's, so I'm going to have 1, 2, 3, 4, 5, 6, 7, and 8. And I have 4 positives. I got 1, 2, 3, and 4. On the right side, I have 6 negative x's. 3, 4, 5, and 6. And then I have 10 positive ones. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, you want to make sure you can get this practice down with drawing the pictures and with using the model. So now, just like before, we want to get all the variables to one side. I usually add the lower coefficient to both sides. So I'm going to add 8 positive x's to both sides. I do that by kind of putting them next to each other. On your paper, if you want to, you can put them side by side. That way you can do those 0 pairs, but as long as you're able to kind of see what you're aiming for. So again, I'm going to add 8 positive x's to both sides. The reason why I'm doing that is I'm trying to get rid of those variable terms on the left and move them to the right side. And what I should end up with on the right is 2 positive x, and I have my 0 pairs. So let's cancel those out. Again, at any point in time, you can pause, rewind, anything like that for yourself. And so if you notice, what do we have? Well, we have 4 positives equals 10 positives and 2 positive x's. Since I have my variables on this right side, I can now get my constants, or my 1s, to the left side. So I'm going to do just that. I'm going to add the opposite to both sides. So I'm going to add 10 negatives to both sides. Again, you can put them next to each other or on top, as long as you can make those 0 pairs, and that way you can still see them. Alright, so I got 1, 2, 3, 4, I got 5, 6, 7, 8, 9, and 10. Again, be able to cancel out those 0 pairs. So all these go away, and all those go away. And so what are we left with? Well, we're left with 2x equals -6. And so how does this work? Well, to be able to show division, again, you can do it one of 2 ways. You can group them like this, and so you can say, all right, I can take these 6 negatives, and I'm going to, one by one, split them into 2 equal groups. And then you can circle those equal groups. So I have 1 and 2 equal groups, and so I'd say 1x equals 3 negatives. Another way you could do it is the way that Juan showed me. Again, be able to see how this works. And he said, hey, let's put these 1s inside of those x's. So I'm going to just put them inside, that way I can kind of see how they work. Again, inside of 1x is 3 negatives. Alright, if you don't like that way, that's totally fine, but you want to be able to show you have multiple ways for yourself. And so again, the steps I did was just like this. I added 8 x's to both sides. And so what was I left with? Well, I was left with this. I was left with, on the left side, I just have 4, and on the right side, actually need to spread this out a little bit more. Perfect. On the left side, I have a positive 4. That comes down because the 8s cancel out. On the right side, negative 6x plus 8x is 2x. And then I have that positive 10 comes down. Now we can subtract 10 from both sides, like so. The 10s cancel out, so let me actually cancel those out. And we're left with negative 6 equals 2x. And just like we showed before, again, we divide both sides by the coefficient, and we end up with x equals a negative 3. Be able to check for yourself like we've been doing. Again, I'll show, let's see, let me make this a little bit smaller. Let me actually do it. Can I shift this over? Oh yeah. I'm going to put that there, and I put this here. Alright, so we said again, in green I'll do my first line, and in pink I will do my second line, and we'll check our answer. So using that Desmos calculator, again, I can type for myself. I say negative 8x plus 4, and then I have my pink line, which is negative 6x plus 10, and then we define our variable as x equals negative 3. Again, since these two lines are equal, we know that our answer of negative 3 is correct.